Okay, so hey y'all, it's Vamily, and I got question from 2019 question 1 and question 2016 question 6. And the question reads, the compound urea is widely used in chemical fertilizers. The complete Lewis diagram for the urea molecule is shown above. And question A asks, part A, identify the hybridization of the valence orbitals of the carbon atom in the urea molecule. So in the urea molecule, this would be the carbon atom. So what I had done, or what I would do, is that I would circle the part of the urea molecule that I'm looking at, and then to identify the hybridization in class, like the trick that we learned was to count the number of bonds around. So it doesn't matter if it's single or double, you count it as one. So it'll be 1, 2, 3, and then subtract 1. So this would be sp2 hybridized, basically, right? So that would be my answer. So in part B, they show us a diagram and they include H2O and the urea molecule, and they separate them by little circles. So basically, if I were to draw them out, it would look like this. Then it has a little whatever. Then 1, 2, 1, 2. And this is the H2O molecule that's like on the side, right? On the sides. And the question reads, urea has a high solubility in water due to part to its ability to form hydrogen bonds. A urea molecule and 4 water molecules are represented in the box below. Draw one dashed line to indicate the possible location of a hydrogen bond between water molecules and the urea molecule. So when I was looking at this, where would the bond be? I know these are H's, and this is an O. There's an O here. Exactly. So since the O can bond and it has electrons surrounding it, the hydrogen bond that I drew was between the the H and the O. That's the hydrogen bond that I drew. Okay. So then part C said calculate the concentration of urea in the saturated solution. So they asked for it in moles per liter, and then saturated solution at 20 degrees Celsius. This is like me annotating my question. So in the question, in the part C, right above part C, they give us that we have 5.39 grams of the urea. So then we're going to multiply by the ratio to turn it into moles. And that's going to be 0.0897 moles. But then they also wanted in moles per liter. So I just multiplied by 1 over 0.005 liters, and I changed this from milliliters to liters. And it gave me an answer of 7.9 moles per liter. And this would be the concentration at 20 degrees Celsius. So for part D, so the question reads, the student also determines that the concentration of urea at 25 degrees Celsius is 19.8 molarity. Based on the information in the dissociation of urea, is it endothermic or exothermic? Justify your answer in terms of Le Chatelier's principle. So basically, the question said, as the temperature increases, the concentration of urea also increases as well. So I looked at the reaction equation that they gave us, H2 NCO and H2S. Ooh, my handwriting is not cute. H2NCO and H2 aqueous, right? So as the temperature increased, the concentration of the urea increased. This part increased. So if temperature increases and it's creating more of this, I had said that the reaction is exothermic and was shifting The next question I got was question 6 from the 2016 FRQ, which I'm pretty sure, definitely sure we've done in class before. And the question reads, the polyatomic ion C10H12N2O84- is commonly abbreviated as EDTA4-. The ion can form complexes with metal ions in aqueous solutions. A complex of EDTA4- with Ba2 plus ion forms according to the equation above. A 50 milliliter volume of solution has an EDTA4- aqueous solution of 0.3 molarity, is mixed with a 50 milliliter of 0.2 molarity B of that to produce 100 milliliters of solution. Okay, so question A asks, considering the value of K for the reaction, determine the concentration of Ba EDTA2- aqueous in the 100 milliliter of solution. Justify your answer. So when we went to look at our K value, we saw that the K value was 7.7 times 10 to the negative, times 10 to the positive 7. So this is a big K, which also means that basically the reaction goes into completion, right? So what that also means is that there's more products. Therefore, the concentration of Ba EDTA 2- is high, right? So in order to actually find the real concentration of BETA, okay, so we have 50 milliliters of 0.3 of EDTA and 50 milliliters of 0.2 BA. So molarity equals moles over liters. So if you do that calculation and we find for moles, for BA, the moles would be 0.01 moles, and for EDTA, the moles would be 0.015 moles. And since this hasn't yet been created, this would be 0M, right? So if we were to, do our rice, here is the change. So it's minus x plus x, but since we know Ba dissociates completely, we know this will also be 0.01 mole, right? Which means x is 0.01. But they want to know, so once we know molarity for our Ba EDTA, now we can find, since we now know the moles for our Ba EDTA, we can now find for molarity. So molarity equals 0.01 moles over 0.1 liters. So this would be 0.10 molarity of Ba EDTA 2-. Oops, I made a mistake. It's not 0.1. It's 0.01. 0.01 liters equals this amount. Sorry. And now our last problem, or our last part of the problem, is part B. The solution is diluted with distilled water to a total volume of 1 liter. After equilibrium has been reestablished, and the number of moles of Ba2 plus present in the solution greater than, less than, or equal to the number of moles of Ba present in the original solution before it was diluted to justify your answer. So now we're dealing with, changes in concentration by adding H2O. So they want us, so basically, Le Chatelier problems, we usually use the values of K and Q to determine where the reaction shifted towards. Was it the reverse reaction or the forward reaction? And that's basically it. So when we have, basically right now we have Q equals Ba EDTA 2- the initial, Ba2 plus EDTA. 4 minus, right? But we know that the solution went from 0.1 liters to 1 liter. So this was multiplied by 10. So if the volume increases by a multiple of 10, then the concentration decreases. So you just had to multiply the concentration by 110. So if we were to have Q equals BA EDTA 2 minus over BA 2 plus and EDTA as we have above. I don't know why I rewrote that. But you can multiply all these by the coefficient of 110 just because we know that the change in volume causes this change in concentration. These two will cross out, but you still be left with a 110 here. So whatever K value you get will have a coefficient of 10 K. So Q is equal to 10 times K. So Q is greater than K, which means you have more products. So if you have more products and to maintain equilibrium, you would shift to the left. And thus you will make more Ba2 plus. And if you make more Ba2 plus, then the answer would be increasing. Right? You see that?